Hey guys, welcome back. This is the final episode for our Z80 RC2014 Classic II project that we got from Z80kits.com. So this is the project we've been working on. If you're just tuning in, go back and I'll show you how we build out each of the PCBs. In this episode, however, we are actually going to put power to the device. Hopefully not releasing any of the magic smoke. We're going to hook a serial interface to it, boot it, and hopefully bring up Microsoft Basic. Also, I'm going to take a look at the ROM, and we're going to program a couple additional pieces of software into the ROM and take a look at those. All right, stay tuned. All right, so we are at the point of wanting to power this bad boy on. So I want to show you a couple things. For one, when you pull these out of the backplane, be careful. Try to pull straight up. Otherwise, you can actually bend the pins a little bit. And if you do that, you definitely want to make sure you straighten it back out again. It's actually a common problem to try to kind of wedge it out of here and bend them. So just keep an eye on that. This is the serial I/O PCB. And if you remember, there's a jumper on it. And it says, I don't know if I can show that to you, but yours will say 5 volt power from FTDI, which is the interface to the serial, which is right here. Let's see. So this is the, I think you call it a CDC adapter. It interfaces USB to serial output. So if you're going to power your device with that, you need to make sure that this jumper is on. And you can even see on my board, I did not install the rest of the components. Like I did not install the barrel jack or the female barrel jack for the power, or the decoupling caps, or the voltage regulator. I did not do that. I'm using all the power from the USB. Now when you hook yours up for the first time, you're going to want to look at the back of this serial board. If you notice, it's got the color codes for what is typically used for a serial interface. But your CDC does not have those same color codes on it. So when you plug it in, what you really want to do is just make sure that ground goes to black. Ground goes to black. And you'll know that you've got it right if you can get that one. So that's it. So with that jumper on and this, we should be able to power this on. So let's plug it in, make sure that all the pins are in. All right. And let's put some power to it. So this is connected to my computer. We'll do this. I'm trying to think the best way to do this for you. Let's just apply power, not worry about the terminal software, and make sure that we get the LED lit and that we have power, or it appears as though we have power. So if I plug this in, all right, so we do. If you can see that, there is a green LED lit, which is a really good sign. If you don't have that, that's where we're going to have to go back through and do some debugging. It's a pretty simple design. So the first things I would do, excuse me, is check the voltage at your pins. Make sure that you actually have 5 volts coming in. And you should have 5 volts. And I mean, at the very least, you can start pulling out some of the boards. Start with your serial I/O board and see that you've got a 5 volts on that bus. That's probably the easiest thing. So now that I've got power on mine, what we want to do is check the jumpers. So I'm going to unplug the power so I can show you this. Now, there's these jumpers that come with it. This is the ROM PCB. And we're going to play with that in just a little while. But one of the sheets that I made for you shows in the ROM where everything is. So really at address 0 you've got basic, and at E1000 you've got the monitor, a small computer monitor. SCM is what they call it. So with the jumpers removed, zeros, or actually, you can actually force them to ground. So if they're not already. So basically, it would be that they would be up here. I'm using a pair of tweezers to get them out. Okay. So let's set them so that we know for a fact everything is ground. So that's ground. So we're setting them to zeros. And if you don't know, if this is confusing, if you look, there is a 0 right there. And I am putting the jumpers so that they select the middle pin and 0. To get a 1, you're going to select the middle pin and the last one. So that should give us basic. So we're going to go to the computer. I am going to, let's see here. Okay. So on the screen, I am using this software called TeraTerm. I downloaded it. It was recommended on one of the RC2014 sites. So on my computer, so we're going to go ahead and plug it in. We're going to go ahead and plug in the USB to the computer like I already had, and to the CDC adapter. We've got power. I see that again glowing. Now on the computer, you can see I'm running TeraTerm, and let me see what the setup is. Oh, I'm on the wrong thing. Need to be over here. Okay. So under setup, serial, you want to make sure you've got the proper COM port set for your computer. It might not be COM3 for you. You definitely want 115 kilobits per second, or that's probably bits per second, yeah. 8-bit, none, 1, and all of this is in his documentation. It's in this paperwork. So with that, we should be able to hit reset, and I'm hoping we'll see something on the screen. There you go. Look at that. Oh, very cool. So what is it running, though? Memory top, and I think he says in the instructions just press enter. And then it comes up and says Z80 Basic 7.4b, copyright 1978 by Microsoft, 32K in memory. So there we go. We actually created a computer. We built a computer. Now, agreed, Spencer Owen did this design. And by the way, we're going to have an interview with Spencer in one of the next episodes when I could schedule it with him and talk to him about this design. But we actually built an 8-bit computer, 16-bit address bus on a Z80, and we're actually running the 1978 version. It's been modified to support the address ports. The serial ports on this machine, and we kind of talked about how those ports were laid out, but we've actually got a version of BASIC running. We should be able to write a program. Now, I'm going to include in the link a link to the NAS BASIC, I think is what it's called, the version of BASIC that this is running. Off the top of my head, I don't remember what it is, but you can actually look at that code, play with it, reassemble it, all sorts of stuff. But yeah, so we should be able to type in. I don't remember much BASIC. I used to do it on my Atari 800, but we should be able to do like a 10. I don't know if it's case sensitive. Print, learn. I don't know if that's going to work either. The backspacing. Learn something new every day. Yeah, I don't know if the backspacing is going to work. So let's just run that and see if it works. Okay. So if we go list, I keep screwing up because I'm not used to using this laptop, but 20, go to 10. Go to 10. List, run. Yep. I mean, there's nothing more cooler than that. I mean, not the program, obviously, but the fact that we have just taken serial input. We've got a processor running. We got memory. We got an ancient version of Microsoft BASIC running, and we can actually write some software and make it do something. I mean, back in the late 70s, early 80s, I mean, that was pretty amazing at those times. And to be able to do it at your home you know, with a ZX 100 or a Sinclair or TRS-80 or like what I had, which was the Atari computers. That's pretty amazing stuff. So let's try something else. I'm going to hit reset. I want to see what comes up. So if I now hit enter on my terminal, okay, you can't see that for some reason. I don't know why. Let me see if I can pull this down. No? Okay. Hopefully you can see that now. So it comes up and it asks us, is it doing a cold boot, a warm boot, or we'll go into the monitor. The monitor is probably something similar to the small computer monitor, but it's not going to be the exact same one because we don't have it selected. So we can say cold or warm, and that probably determines what it does in terms of memory. We'd have to look at the code to see. But if we do, let's do warm real quick and see if our program is still there. Yeah, so if we do warm, then obviously it's not clearing memory. Let's do that again, and let's say cold. And now let's list it, and there's nothing. So there you go. Okay, well let's try the small computer monitor and see what that's all about. So what I'm going to do is remove power. I am going to, looking at my cheat sheet here, it's all ones for the monitor starting at E1000. So let me use my tweezers here. I don't know, this is just so cool to me. Maybe I'm just super geeky, but I mean the idea that we're actually running this code. Okay, so now what we've done is we've selected what's called the monitor. And before we power on, there is some information online. I'll give you a couple links to information. There's a number of commands. So what the monitor allows you to do is a number of things. We can actually see some of the commands here. You can do things like assemble an instruction at an address. You can set a breakpoint. You can, looks like output to a port, go to a specific program in memory, fill some memory, edit some memory, step one instructions, so go through steppers. Anyway, there's a whole bunch of things that you can actually do with a small computer monitor. So this was to help you basically debug back in the day. So let's try something. I'm thinking, let's go ahead and put some power to this. So I just need to make sure again that my ground and black are going together. And they are. Okay, so I've got my power light on again. So going back to the computer, oh, it already came up. I'm going to hit reset. Yeah, so we're already there. It says small computer monitor RC2014. Let me try a question mark and see if it comes up with anything. It does. Okay, so there's your commands. And we have the ability to look at memory, assemble, display, memory display, so specific addresses. So if we actually said M0, that's going to be basically, so remember, right now we might have these jumpers set. And technically inside the ROM, we are addressing a E1000. But that, remember, that's mapped to address 0 right now. So that is like an abstraction, or it's a mapping. Basically, the address space in the Z80 is being, the address in the ROM is being mapped to the address space that the Z80 is looking at. So remember, we have the ROM in the bottom of memory, bottom 8K if I remember right, and then we have the RAM above that. So the entire address space of a Z80 is only 64K. So we've got the 32, unless you're going to do bank switching and stuff. So yeah, so we've moved that, we've made that E1000 address in the ROM appear at the 0 address. And this is code for that's what we're looking at on the screen right now. This is code in assembly language for the monitor that we're running. So in theory, let's try something. See, there you go. There's even some text. Small computer monitor, device detected, with some instructions and stuff. So there you go. I'm going to hit Control C, hopefully. Yes, and that breaks me out. Now what we can do is, let's, okay. So if you remember right, I didn't think this all the way through, so I do apologize, but I'm kind of doing it as I turned it on. I'm kind of excited. You remember how we mapped port addresses into the memory space? So if you go back and look at like the serial I/O, we have put that at 80 and 81 hex. So if we look at the instructions here, I saw one that said, yeah, output to a port and data. So port 80, I believe, is input, and port 81 was output. So if we do an, let's see, we do output, port 81, and then let's do an A. So I'm giving it an ASCII code. I believe hex 41 is a capital A. And if I hit enter, we should see an A on the screen. There you go. So with that command just now, we output the ASCII equivalent of A to the screen. That's pretty cool. So now we've got a computer and we've got a bus. We can add things to it. We can play around with it. Also, this ROM that we have here has a lot of blank spaces. And I talked to Spencer Owen, and you can write once to each of these free spaces. So I was thinking we would try to go over and use my other machine and program. I have an EEPROM programmer, which I might do an episode on at another time, and we'll program this EEPROM with some software I download from the internet to, I don't know, to do something. We'll program it. You'll see how I program the EEPROM, or the ROM, it's an EEPROM. And then we'll come back and actually see if we can make whatever I download work. All right, cool. All right, guys, stay tuned. Okay, so what we're going to do is program the EEPROM that came with the kit. A little bit of learning was involved with this process when I did it, because for the longest time I couldn't get it to program, and I realized what the problem was. So let me share it with you. For starters, the schematic actually has the wrong part number. It probably was the right part number. It's a 27 something number. And that's what I thought I had, because I actually had a tag over mine. But if you look on the PCB, there's a different part number, this SST39SF part number. But that didn't work either for me. So I took the tag off, and I realized that mine actually says 39SF010A, and you really have to have the right part when it comes to programming these EEPROMs. This is my EEPROM programmer. I believe it's called a TL, yeah, it's called a TL8662 Plus. It's from China. The software is also from China, so take that as you will when you go to install it. I'm not certain there's any other open source options, but the software seems to work, and I haven't had any ill effects that at least I'm aware of from installing it. So what we do is we pull this out and we drop it into this ZIF socket. And what ZIF stands for is zero insertion force, and we want to make sure that it is pointing in the correct direction. And we got all the pins in. And then you want to go ahead and pull this lever down, which locks it in place. And then if we go over to the computer, we choose the correct part, which I already did, it looks like. And then we click read. And it goes off, there we go. And it reads the EEPROM. So this is the data that's on it. In fact, you can even see, remember that question, that's cold boot, warm boot stuff? There it is right there. Yep. So now what we want to do is we want to program something else on it. And there's a couple different ways you go about that. If you remember, based on these open areas, you can drop things into these programmable areas. Since you can really reprogram this chip multiple times, I grabbed a copy of what was on there so I could restore it. And I didn't really want to have to mess with all the jumpers, though that's not a big deal. I'm going to go ahead and put my stuff at 0, just to make it easier. So if you remember right, zeros, you basically want all of your jumpers. Let's see here. At the top, the center to 0 right there. I think I'm putting some of these in backwards, but I guess it doesn't matter. Okay. So back over here, I've got some software. Let's see, where did I put it? I think it is on the ROM. So let's go File, Load. Now let me go on my network drive, I think. ROMs. Okay. So we have this Pi GFX test, which is supposed to do some kind of color testing. So let's try that out real quick. And by the way, this is the copy of the ROM. So I'm going to go ahead and choose this. Say OK. We want to do an erase and then a verify. So it's actually going to erase the contents on the chip. We're going to click Program, and we're going to program it. OK. Now what we want to do is pull it out. Put it back in. Install it back into the computer. And we need to start that terminal program back up again. So let me do that real quick. Okay. And I'm going to power it up. My terminal software remembers the settings and the ports and everything. I'm going to hit reset. Well, let's see what's going on here. Serial port, COM3, new open, reset. There we go. So we've got hellos in multiple colors kind of showing up on the screen there. So that's what that piece of code does. I guess it's testing however it's doing the color codes. Normally that's some kind of, like I said, like VT terminal or ANSI terminal codes or something. I don't remember. It's been a long time since I looked at that stuff. Let's try one more. There's a snake game. So we move the power, come back over here, pull this out. Somewhere I have a chip puller, but I just do it this way. We will bring the programmer back over. Switch back over to the programmer. Drop our ROM into the programmer. Go down, and let's see what else we've got. I'm going to load. I think there's a snake game that works. Oh, and there's also this TinyBasicPlus. I'll talk to you about that. Let's put the snake game in first. Say OK. Do the erase. It's going to load it. Let's program it. All right, so we programmed it. It's that simple, that fast. Pull it out. Add it back to the ROM board. Make sure you're putting it in the right direction. Okay. Okay, now we will plug in and switch over to the terminal. And we will power it on. And we probably need to hit reset. And maybe choose the port, because I keep unplugging and sharing the same port. So that might be screwing things up a bit. Okay, so the game's not working, but why? Let's do a reset. Make sure I didn't screw anything up. No, that all looks good. All the pins. So let's remove the power. Didn't bend any pins. So it looks like the snake game doesn't work. Make sure that didn't change ports on me. That can happen. No. That's me. That's not the game. Oh, there it is. Man, that terminal software is very squirrely. I don't think it's the computer. I mean, I think it's the laptop, the software on the laptop. It's like losing where it's at. So there we go. We do have the game working. Let me just quickly see why that. Well, it's not worth it. I have a feeling that it's the terminal software. But look, okay. So now at the bottom we press N. We use W, A, S, and D to move it around. W, A, S, and D. I'm going to press N. Game over. So I suck. Oh, that's interesting. I don't know if the... There we go. I got one, got longer. Got another. Anyway, okay, so we got the snake game working. So what I'm going to do in this case is, let's try the TinyBasicPlus, and we'll do a test also with the terminal software to see if it's going to happen to you. So again, I'm going to pull out the PROM. Again, you got to be careful about bending the legs. Let's go ahead and I'm going to unplug the USB port, plug in the EEPROM. Maybe I should just grab a hub, but okay, we're going to put them in. Let's see, put it in, zip it down, tighten it up. There we go. Let's switch over to the programmer again. And let's load TinyBasicPlus. Now, I haven't played with this at all. It's supposed to be a version that you can actually save files to the EEPROM. So that whole issue with saving stuff kind of goes away. So if this actually works, you gotta have to play with it yourself. I don't really have time to mess with it, but it's certainly something you might want to give it a try. That way you can actually save software. I might have mentioned, I'm thinking about doing the CPM enhancement to this project. So if that's the case, we should have better storage capabilities. Okay, so I think I loaded it. We just need to program it. Okay, so that's it. So I'm going to remove the ROM again. I'm going to unplug the programmer. I'm going to plug in the USB. Put the ROM back. This will be the last thing that we look at if it works. Put the ROM back in. Put it back here. Now we're going to power it all up. And when I go over to the, oh, it looks like we lost video for something. I don't know why. Let's see. Sorry about that. Okay, so now that we've got that set up, we've already done the programming of the ROM. Let's go over here. Let's go to, there was a reset terminal. Let's go to serial port. Let's choose, and then let's choose it. Oh, let's choose it, and then let's go back and choose it again, because I don't think it's really resetting. So there we go. Now let's hit reset. Okay, so this looks like a mess. So let me see if I can clear the screen. You guys are probably saying, oh, there it is. Clear the screen, clear screen. Okay, so let me hit enter again. Let me do a reset. Okay, there we go, TinyBasicPlus. It is working. So supposedly with this version, like I said, you can share some things. I'm sorry, store some things. I don't know the commands to do that, but all right. So anyway, we've been able to program the ROMs. We found some ROMs online. I'm going to give you the links to those. If you're interested in how you program EEPROMs and stuff, maybe I'll do a better video on it. But to be honest, it's pretty much what I just showed you. There's really not much more to it than that. All right, this has been a really cool project. I mean, it's really been exciting. There's a lot of stuff you can do with this. Maybe we'll, like I said, continue to do some projects with it. Maybe we'll design some boards to go in it, or we talked about the CPM upgrade. So we'll see. Hey, remember, learn something new every day, and thanks for watching. Take care.